Hello students, welcome back to Disha PU online classes. So you all know that in the previous video we started with the new chapter, that is sequences and series, right? So in that video we have learnt about that is we have seen the definition of the sequences, definition of the series, we have seen some of the examples on that, right? We have known we came to know about finite and infinite sequences, Fibonacci sequences, right? And also we have started with what the problems based on sequences and series, right? That is exercise problems. So today we will continue with the remaining problems, and after that we will study what is meant by arithmetic progression. That is the next concept of our chapter, right? So now let us begin with the remaining problems. So already we have completed two problems, right? So the third one, what is the 20th term of the sequence defined by an is equal to, see here the sequence is defined as what? An is equal to n minus 1, 2 minus n into 3 plus n. I have already told you that an is nothing but what? The nth term or the general term of the sequence, right? So we are given the general term of the sequence. So what we have to find? We have to find the 20th term of the given sequence, right? So how to find the 20th term of the given sequence? So in the definition, while explaining about the definition, I have told you that the terms of the sequences are written as A1, A2, A3, so on, AN and so on, right? And I have told you that here the subscripts which I have written, these represent the position of each term of the sequence, right? So now, in the previous examples you just see, in the previous two problems, in the first problem we have calculated the first three terms of the sequences, and in the second problem we have calculated first five terms of the sequences, right? So first three terms in the sense what? A1, A2, A3, that is, this is the first term, it is the second term, it is the third term, and it is the nth term, right? So 1 represents the first position of the element. In the same way, 2 represents what? The second position of the element, that is second term. So here we are asked to find out the 20th term of the sequence. So what do you mean by that? N is equal to what? 20, right? So at the 20th position of the sequence, what is the term that we have? We have to find out that. So to find that, what we have to do? We have to put 20 in the place of n, right? So let us substitute that and let us find the solution. Now, solution, right? First write the given sequence. Given, what is given? An is equal to n minus 1, 2 minus n, 3 plus n, right? So what we have to find? We have to find the 20th term here, right? So for that what we have to do? Put n is equal to 20. So it becomes what? A20. A20 in the sense the element or the term of the sequence is present at which position? 20th position, right? So this is equal to n is 20 minus 1, 2 minus 20, right? And this is 3 plus 20, right? So A20 is equal to 20 minus 1 is what? 19, right? 2 minus 20 is what? Minus 18, right? 3 plus 20 is what? 23, right? So when you multiply all these three terms, your answer will be what? Minus 7866. can calculate this. You can multiply all the terms. When you multiply these three terms, the answer will be what? Minus 7866. So this is your what? The 20th term of the given sequence. Right? So this is how you find the particularly mentioned term of the sequence. Right? So write the solution. And at last what you will write? The required 20th term is minus 7866. Right? So now let us move on to the next question. Right. So the next one. Fourth question. Find the indicated terms in each of the following sequences. See, we are given some sequences and we are given to find the indicated terms here, right? That is, see, the first question in that. What is the sequence given? An is equal to 4n minus 3, right? And what are the terms that we are asked to find? A17 and A24, right? So, A1 means what? The first term. A2 means what? The second term. Here we are asked to find what? A17. What do you mean by A17? The 17th term of the sequence. A24 means what? The 24th term of the sequence. Right? So we have to find those now. Right? So first let us find the 17th term of the sequence. Right? See here. Solution. First write given. What is given? An is equal to 4n minus 3. Right? Now, what is the first thing that we have to find? A17, that is the 17th term. So, in the place of n, what we have to put? We have to substitute 17. Right? So, now first thing is put n is equal to 17. Right? Let us take this as 1. Equation number 1. So put n is equal to 17 in 1. Right? So now this becomes what? A17 equal to 4 into 17 minus 3. Right? So this is equal to what is 17 fours? 17 into 4 is what? 68. Right? What is 17 fours? Equal to 68. This is minus 3. Right? So A17 is equal to 17 fours is 68. Right? Minus 3. This is equal to 68 minus 3 is what? 65. So what is your 17th term of the given sequence? That is equal to 65. So this is how you find the indicated terms of the given sequences. Right? So in the same way, let us find out the 24th term of the sequence. So to find the 24th term, what is your value of n? N is equal to what? 24. So put n is equal to 24 in equation number 1. Right? So it becomes what? A24 is equal to 4 into 24 minus 3. This is equal to, it is A24 equal to. So what is 4 into 24? See, 4 4s is 16. 1 carry, 4 2s is 8. 8 plus 1 is 9. So 24 4s is what? 96 minus 3. Right? What is 96 minus 3? It is equal to 93. So your 24th term of the sequence is what? 93. Right? So this is how we find out the indicated terms of the given sequences. I hope you understood this. Take this down. Now we will solve one more question based on this, and there are some remaining questions which will be for your home assignment. Right? So the second question. An is equal to n square divided by 2 power n. Right? So what we have to find out here? We have to find out A7. A7 is nothing but what? The 7th term of the sequence. So to find the seventh term of the sequence, what we have to do? We have to substitute 7 in the place of what? N. Right? So now let us solve that. Solution. See, first write the given sequence, that is an is equal to n square divided by 2 power n. Right? And next is what we have to find out the seventh term. So put n is equal to 7. Right? So what we get? A7 is equal to n square means what? 7 square divided by 2 power n. N is equal to what? 7. Now this is equal to, what is 7 square? 7 square is 49. Right? 2 power 7. 2 power 7 is nothing but what? 2 is multiplied how many times? 2 is multiplied 7 times. So when you multiply 2 7 times, you will get the answer as what? 128. Right? What is 2 power 7? Is equal to 128. That is 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Right? So this is your what? The seventh term of the given sequence, n square divided by 2 power n. Right? So this is how we solve. So remaining 2 questions will be for the home assignment. Write them down. Right. So these 2 questions will be for your homework. So here the sequence is given. You have to find out the 9th term of the sequence. In this question you have to find out the 20th term of the sequence. Right? So these 2 will be for your home assignment. Now let us continue with the next question. See the 5th question. Let the sequence an be defined as follows. Right? So they have defined the sequence as, see, you are given the first term of the sequence here, a1 is equal to 1. Right? And for the remaining terms of the sequences, the sequence is defined as what? An is equal to an minus 1 plus 2. So this is nothing but what? Each term of this sequence is obtained by adding 2 to its preceding term. For example, if, see, I have considered the first term of the sequence, they have given already 1. Right? So your next term of the sequences, how will it be obtained? See here, an is equal to, that is the nth term, n minus 1 means what? The previous term of an. Right? So to the preceding term of an, if I add 2, then I will get what? An. So the terms of the sequence are obtained by adding 2 to the preceding terms. Right? So this is the sequence given for you. For n greater than or equal to 2. Because already the first term is given, so you need what? The next terms. So it starts from 2, 3 and so on. What we are asked to do here? We are asked to find the first 5 terms. Right? We are asked to find the first 5 terms and write the corresponding series. Right? So I have already told you about the series. If a sequence is given, that is A1, A2, so on, A and so on, how will you write the series? The series is given by this expression. Right? So now what we have to do? We have to find the first 5 terms of the sequence and then we have to write those terms in form of series. Right? So now let us start with the solution. See here. Already the first term of the sequence is given. We need to find the first 5 terms. So the first term is already given. So how many terms still we have to find out? We have to find the remaining 4 terms of the sequence. That is second term, third term, fourth term and fifth term. Right? So let us solve that. First solution. First write the given. What is given? An is equal to an minus 1 plus 2. An is equal to an minus 1 plus 2. Let us take this as equation 1. Right? And you are also given the first term of the sequence. Right? And a1 is equal to 1. So we have to find out the first 5 terms. So already the first term is given. So we have to find the second term, third term, fourth term and the fifth term. See, in the first 2 problems already we have solved. That is finding first 3 terms or first 5 terms. So what we have to do? We have to put n is equal to 2, 3, 4, 5. Why? Because first term is given, we are finding the next 4 terms of the sequence. Right? So substitute the value of n one by one in the equation 1. In equation 1. Right? So first, for n is equal to 2, a2 is equal to a2 minus 1 plus 2. See, a2 minus 1 means what? a1, right? So a2 is equal to a1 plus a2. What is the value of a1? It is equal to 1. So 1 plus 2. So this is equal to 3. So what is the second term of the sequence? 3. Now next, put n is equal to 3. a3 is equal to a3 minus 1 plus 2 is equal to a3 minus 1 means what? a2. That is the second term of the sequence. What is the second term of the sequence here? It is 3. So 3 plus 2. This is equal to what? 5. So this is the third term of the sequence. Now put n is equal to 4. a4 is equal to a4 minus 1 plus 2 is equal to 4 minus 1 is 3. So this becomes a3. a3 means the third term of the sequence, that is equal to 5. So 5 plus 2, this is equal to what? 7. Right? And the last term is what? Put n equal to 5. So a5 minus 1 plus 2 is equal to, see, 5 minus 1 is 4. So it becomes a4. What is the fourth term? 7. 7 plus 2 is equal to 9. Right? So these are the first 5 terms of the sequence. Now what we have to do? The next thing, we have to write the corresponding sequence in the form of a series. Right? That is the obtained sequence, we have to write that in the form of a series. Right? So the corresponding series is how will we write the series? 1 plus 3 plus 5 plus 7 plus 9, so on. So this is the corresponding series that is obtained. Right? So this is how you find the terms of the sequence and represent them in the form of a series. Right? So I hope you understood the problem how to solve. Right? So there are some more questions. We will solve 1 or 2 and remaining will be for your home assignment. Right? So the next thing. See, these 3 problems are also based on the previous problem itself. See here. Write the first 5 terms of each of the following sequences and obtain the corresponding series. So same thing, we are given some sequences here. We have to find the first 5 terms and we have to write its corresponding series. Right? So see, the first question will be for your assignment. We have already solved the previous question, right? In the same way you solve this also. The first question will be for your assignment. I will solve the second question and again the third question will be for your home assignment, right? So there will be 2 questions for home assignment, right? So now the second question. See what is given. A1 is equal to -1, right? So write the given here. Given. You write the question separately and solve them. Okay. So second one. Given. An is equal to an minus 1 divided by n. Right? Where n is greater than or equal to 2. Let us consider this as equation number 1. And we are also given the first term of the sequence as a1 is equal to -1. Right? The first term is given. So what we have to do? We have to find out the first 5 terms. So as already the first term is given, what we can do here? We have to find out the next 4 terms of the sequence, that is second term, third term, fourth term and the fifth term. So to find out the next terms, what we have to do? We have to substitute 2, 3, 4 and 5 in place of n. Right? So let us carry on with that. See, put n is equal to 2, 3, 4, 5 in equation number 1 at a time, right? Okay, sorry, one by one, right? So see here, first put n is equal to 2. A2 is equal to A2 minus 1 divided by 2, right? This is equal to, what is 2 minus 1? A1 divided by 2. What is A1 is equal to? Minus 1 divided by 2. This is the second term of the sequence, right? So now put n is equal to 3. A3 is equal to A3 minus 1 divided by 3, right? This is equal to A2 by 3, that is 3 minus 1 is 2. What is the value of A2 that we have got here? Minus 1 by 2. So minus 1 by 2 divided by 3. See, this also comes to the denominator. What is 2 into 3? 6. So that is minus 1 by 6. Right? Or else you can take 3 by 1 reciprocal, that will be into 1 by 3. So minus 1 by 2 into 1 by 3 will be minus 1 by 6. So this is the third term of the sequence. Next again put n is equal to 4. That will be A4 minus 1 divided by 4. So this is equal to A3 divided by 4. What is A3 is equal to? Minus 1 by 6 divided by 4. So this will be minus 1 divided by 24. Right? See here. Minus 1 by 6 divided by 4 in the sense minus 1 by 6 divided by 4 by 1. I can write this as what? Minus 1 by 6 into 1 by 4. Right? This will be reciprocal when I change this to multiplication. So this will be equal to minus 1 by 20. Right? So in the same way also I have written this answer. Now, the last term, that is put n is equal to 5. A5 minus 1 divided by 5 is equal to 5 minus 1 is 4. So A4 divided by 5 is equal to, what is A4 is equal to? Minus 1 divided by 24. So minus 1 by 24 divided by 5. This is equal to what? Minus 1 divided by 120. When you multiply 24 with 5, the answer will be what? 120. So these are what? The first 5 terms of the sequences, that is minus 1, minus 1 by 2, minus 1 by 6, minus 1 by 24 and minus 1 by 120. Right? So what we have to do? The next thing is we have to obtain the corresponding series for those terms. Right? So write the series now. See the corresponding series. The corresponding series is, see, minus 1 plus of minus 1 by 2 plus of minus 1 by 6 plus of minus 1 by 24 plus of minus 1 by 120 plus so on. Right? So you can also write this as like this. See, minus 1 plus into minus is what? Minus. So minus 1 by 2, minus 1 by 6, minus 1 by 24, minus 1 by 120, so on, minus so on. Right? So all the terms that you get is what? Negative. So this is the corresponding series that you will get. Right? So the third question will be for your homework, and there is remaining one question. We will solve that and we will go for arithmetic progression. Alright, so the last question. The Fibonacci sequence, is defined by 1 is equal to a1 is equal to a2 and an is equal to an minus 1 plus an minus 2, n is greater than 2. Find an plus 1 divided by an for n is equal to 1, 2, 3, 4 and 5. Right? So we have already learned about the Fibonacci sequence. Right? So see here. The Fibonacci sequence is defined like this. That is, the first two terms of the sequence is given equal. That is, first term is also equal to 1 and the second term is also equal to 1. And the next terms of the sequences are to be determined by using this sequence. That is, an is equal to an minus 1 plus an minus 2. Right? While explaining, I have told you that the next terms will be obtained by the addition of the previous two terms. So here the same thing is going on. When you add the previous two terms of the sequence, you will be getting an. n minus 1 is also the previous term to n. n minus 2 is previous term to n minus 1 and n. Right? That is previous term to n minus 1. So when you add those two, you will be getting an. Right? So what we have to do? We have to find an plus 1 divided by an for these values of n. That is 1, 2, 3, 4, 5. Now, put n is equal to 1 first. You will get 1 plus 1 is what? 2. So a2 divided by an. So you have a1. You have a2 as well as a1. So you can find for n is equal to 1. Right? So now put n is equal to 2. 2 plus 1 is what? 3. So a3 divided by a2. See here, you have the value of a2. That is, you know what is the value of a2. But do you know the value of a3? No, right? So we need the value of a3. In the same way, when you put n is equal to 3, you will get a4 here. You don't know the value of a4. When you put 4 in place of n, you will get a5. You don't know the value of a5. When you put 5 here, you will get a6. You don't know the value of a6. So, before solving this, what we need to know? We need to know the value of a3. We need to know the value of a4, a5 as well as a6. So these four values can be obtained by using this sequence. Right? So now let us solve this. Solution. Given. What is given? an is equal to an minus 1 plus an minus 2, where n is greater than 2. Right? So let us take this as 1. Now, and also we are given that first two terms of the sequence are equal and they are equal to 1. Right? So to find out this, we need the values of a3, a4, a5 and a6. Right? So already we have a1 and a2. So the next thing is what we need? a3. So if I put n is equal to 3 here, will I get the third term of the sequence? Exactly. So put n is equal to 3 in equation 1. Right? So what will be the solution for this? a3 is equal to a3 minus 1 plus a3 minus 2 is equal to, what is 3 minus 1? 2. So a2. What is 3 minus 2? 1 plus A1. So A3 is equal to, see it is A2 plus A1. What is A1 and A2 are equal to? A1 and A2 are equal to 1. So 1 plus 1. This is equal to 2. So what is A3 is equal to 2. Right? Do you understand the point? Right. So next thing we need is what? The value of A4. Right? So let us find the value of A4. See. So to find the value of A4, what will you do? You will put the value of n as 4. So put n is equal to 4 in equation 1. Right? So what will it be? A4 is equal to A4 minus 1 plus A4 minus 2 plus A4 minus 2. Right? So this is equal to 4 minus 1 is 3. So this is A3. 4 minus 2 is 2. So this is 8. Right? So this is equal to, what is the value of A3 that we have got? Equal to 2. What is the value of A2? Equal to 1. So substitute them there. 2 plus 1. So this is equal to 3. So A4 is equal to what? It is equal to 3. Right? So in the same way, let us find the value of A5. So put n is equal to 5 in equation 1. So it will be A5 is equal to A5 minus 1 plus A5 minus 2. So this will be equal to A4 plus A3 equal to, see, the value of A4 is 3 and the value of A3 is 2. So substitute them there. 3 plus 2. So the value of A5 will be 5. Right? So now the last value that we have to find is what? A6. Right? So note this down. Note this down first. Right. So now let us find the value of A6. Right. So we will find the value of A6 now. So put n is equal to 6 in equation 1. So what was our equation? An is equal to, so n is equal to 6 here. So A6 equal to An minus 1, that is A6 minus 1 plus An minus 2, that is 6 minus 2. So this is equal to A5 plus A4. Right? So A6 is equal to, see here, what is the value of A5 that we have got? 5. What is the value of A4 that we have got? 3. So add them. 5 plus 3, that is equal to. So this is the value of your A6. So now we have got all the values A1, A2, A3, A4 and A5 and A6. So now let us find the asked question. What are we asked to find? An plus the value of An plus 1 divided by An. For the values of n is equal to 1, 2, 3, 4 and 5. Right? So one by one we will solve. Right? So now, see, I will write the values of A1 and A2 that we have got here. See, A1 is equal to A2 is equal to 1. A3 is equal to, we have got 2. A4 is equal to, we have got 3. A5 is equal to, so we have got 5 and A6 we have got 8. Right? So I have written that for the reference while solving the given question. Right. So what we are asked to find? An plus 1 divided by An. Right? So for the values of n is equal to 1, 2, 3, 4 and 5. So now first, for n is equal to 1, An plus 1 divided by an is equal to, what is n is equal to 1? Sorry, what is n is equal to? We are taking it as 1. So a1 plus 1 divided by a1, that is a2 divided by a1 equal to what? a2 is also 1 and a1 is also 1. So 1 divided by 1 is equal to 1. Right? So for n is equal to 1, an plus 1 divided by an is equal to what? 1. Next, for n is equal to 2, an plus 1 divided by an is equal to, right? So we are substituting n is equal to 2. So a2 plus 1 divided by a2 is equal to what? 2 plus 1 is 3. So that is a3 divided by a2. What is the value of a3 that we have got? That is equal to 2. So 2 divided by, what is the value of a2? 1. So 2 divided by 1 is 2. Next, for n is equal to 3. an plus 1 divided by an is equal to a3 plus 1 by a3. 3 plus 1 is 4 divided by a3 equal to, what is the value of a4 and a3 we have got? See, a4 is equal to 3 and a3 is equal to 2. Substitute them here. a4 is 3 and a3 is equal to. So this is the value of an plus 1 by an for n is equal to 3. That is equal to 3 divided by 2. Right? Next, for n is equal to 4. What will be the value? an plus 1 by an equal to a4 plus 1 by a4. 4 plus 1 is 5. So this is a5 by a4. What is the value of a5? 5. What is the value of a4? 3. Right? So this is the value of an plus 1 by an when n is equal to 4. And the last value is for n is equal to 5. an plus 1 by an is equal to a5 plus 1 by a5 is equal to a6 by a5. So what is the value of a6? 8. What is the value of a5? 5. So this is the value of an plus 1 by an for n is equal to 5. Right? So this is how you solve this problem. Right? So I hope you understand this. So note this down. Next we will move with arithmetic progression. Right? Right. So we are finished with the problems from the first exercise now. So the next concept of our topic is what? Arithmetic progression. Arithmetic progression. See, you people are already familiar with the arithmetic progression, right? You have studied this in your 10th standard, right? So let us study one more time here, and we will study a bit more about arithmetic progression, right? So before telling you about the arithmetic progression, let us understand what is meant by a progression first, right? So see here, let me take a sequence. Let us consider one sequence, 1, 2, 3, 4 and so on. So what are these? See, this is a sequence of what? Natural numbers. You can easily tell, right? So in this sequence, as you can see that there is some particular pattern, right? There is some specific pattern that is followed by this sequence. What is that specific pattern? See, each term of the sequence is added by 1, right? When you add 1 to 1, you will get 2. If you add 1 to 2, you will get 3. If you add 1 to 3, you will get 4. So in the same way, the next terms of the sequence also follows the same. That is, next terms of the sequences are also obtained by adding 1 to its previous term, right? So there is some specific pattern that is followed in the sequence, right? So this sequence we can call it a progression. That is, the sequences which follow some specific pattern are called as what? Progressions, right? So let us take one more example. 1, 1, 2, 3, 5, 8, so on. See, this is an example of what a Fibonacci sequence, right? I have already explained you this. Now, see here whether there is any particular pattern that is followed between two elements, two terms. That is, each term, does it follow any specific pattern here? No. See here, first two terms are equal. Next term is obtained by adding 1. Next term is obtained by adding 1 here. Again, next term is obtained when you add 2 to this. Right? So, each term of the sequence doesn't follow any specific pattern so that we can recognize the next term. Right? According to each term here. Right? So, a sequence, this does not become a progression. A sequence is said to be a sequence is said to be a progression when it follows some specific pattern, right? So now coming to the arithmetic progression, you have already studied this, right? You have already studied about the arithmetic progression, right? So what is meant by arithmetic progression? The list of numbers, that is, arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to its preceding term. That is, each term of that sequence is obtained by adding the fixed number to the previous term or previous number except the first term of the sequence. This is how we have studied about what arithmetic progression, right? In short, we will write it as AP, right? So what is arithmetic progression? See, let us take an example. 2, 4, 6, 8, so on. This is a sequence of what? These are even numbers, right? So see here, first term is 2, so except the first term, right? Each and every term is obtained by adding the fixed number. What is that? See, first term you just keep it as it is. 4 is obtained when we add 2 to 2. 6 is obtained when we add 2 to 4, right? 8 is obtained when we add 2 to 6, so on, right? So see here, there is one constant term, there is one fixed term or fixed number with which we are obtaining the next terms of the sequences except the first term. This type of progression is called as what? Arithmetic progression. I hope you understand this, right? This constant term which we are adding to the previous term to obtain the next term is called as what? Common difference. Is called as what? Common difference, right? So this is the first term we call it as first term, right? And the fixed number which we add to get the each term of the sequence is called as what? Common difference. You can also say that if the difference between a term and its preceding term is same or is common for every term of the sequence, then that progression or sequence, that is sequence, is called as what? Arithmetic sequence, or you can also call it as arithmetic progression, right? So this is one example for that. So how we generally represent the arithmetic progression? That is, what is the standard form of arithmetic progression? You already know that. See, let us take first term as what? A, right? So the next term of arithmetic progression, how will be they obtained? They will be obtained by adding the constant term or the fixed number to each term, right? So let us take that as a D. If I add D to this, we will get the second term. Next, add again a D to this, you will get the third term. So it will be A plus 2D, right? Next will be A plus 3D. It goes on, right? This, so on, it goes on like that, right? So in the same way, what is the nth term of the arithmetic progression? An is equal to A plus n minus 1 into D. Right? You have already learned this. The nth term of the arithmetic progression is given by A plus n minus 1 into T, where A is the first term, right? Here An is nothing but nth term. N means what? The number of terms in arithmetic progression. The number of terms of the arithmetic progression, right? And D is what? The common difference. Common difference, right? See, if a progression is arithmetic progression, then obviously the difference between a term and its preceding term for all the terms will be same, right? That is why we call it as what? The common difference, right? So this is the nth term of the arithmetic progression, and this is the standard form of the arithmetic progression, where this is first, second, third, fourth and so on terms, right? So I hope you understand this point, right? So now let us consider arithmetic progression. Let us consider arithmetic progression. That is, just now I have considered the example 2, 4, 6, 8, 10, so on. Right? So now what I will do is, I will take one number and I will add that number to all the terms of the arithmetic progression. Right? So let us take that number as 1. We will add 1 to each and every term of the arithmetic progression, and let us see what we will get, right? So, what is 2 plus 1? 3. What is 4 plus 1? 5. What is 6 plus 1? 7. What is 8 plus 1? 9. 10 plus 1 is 11. Next even number is 12. 12 plus 1 is 13. It goes on, right? So you will get all the numbers by adding 1 to each and every term of the arithmetic progression. Now see this sequence or this progression is an arithmetic progression. We know that. Why? Because the common difference is what? 2. Now check for this. I have added a constant number or a fixed number to this arithmetic progression, and I have obtained a new progression here, right? So now let us see what happens here. What is 5 minus 3? 2. What is 7 minus 5? 2. What is 9 minus 7? 2. 11 minus 9? 2. 13 minus 1? 2. Goes on. Whenever you take a term and subtract that with the previous term, you are getting the same answer, right? That is, the difference is common. We are getting the common difference. So, what is the meaning of this? Whenever you add a term, that is the fixed number, to each and every term of the arithmetic progression, the obtained new progression will also be an arithmetic progression. It will not change, right? you are adding a fixed number 1 to the given arithmetic progression. The obtained progression or the obtained sequence is also arithmetic progression, right? So in the same way, if you subtract a fixed number to each and every term of the arithmetic progression, the obtained progression will be arithmetic progression. There will be no change in that. Even if you multiply with the fixed number to all the terms of the arithmetic progression, the obtained progression will be arithmetic progression. And it is the same for what? Division. If you divide any fixed number to all the terms of this arithmetic progression, the obtained progression will be arithmetic progression. Right? So you understood this? That is, if you add, subtract, multiply or divide with any one fixed number to each term of the given arithmetic progression, the obtained progression will be again a arithmetic progression. Right? So I hope you understood this point. Right? So now, see, you already know that the first term of the arithmetic progression is denoted by A. Right? The last term of the arithmetic progression is denoted by L, right? An is nth term of the arithmetic progression, and D is the common difference of the arithmetic progression. N is number of terms in the arithmetic progression, right? So in the same way, you have also learned that sum of n terms of the arithmetic progression, it is given by what? Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula you use to calculate the sum of n terms of the arithmetic progression, where Sn denotes what? Sum of n terms of the arithmetic progression, right? So this can also be written as n by 2, 2a can be written as a plus a, right, plus n minus 1 into d is equal to n by 2 a plus, see, a plus n minus 1 into d is nothing but what? It is the nth term of the arithmetic progression. So I can write this as an also, right? So if this is the last term of the arithmetic progression, how we can represent the last term? That is equal to n. So this can also be written as what? N by 2 plus a into n. So you can write the formula in these three ways, right? One is n by 2, 2a plus n minus 1 into d, n by 2 a plus an. If it is the last term, that is if the last term is given, then n by 2 into a plus n, right? So this is what the sum of n terms of the arithmetic progression. So this is about arithmetic progression. So now what we will do? We will begin with the problems based on the arithmetic progression, right? Right. So write the definition of the arithmetic progression, and you also know about the standard form, and also take this down. Alright, so see here, I have written that a sequence a1, a2, a3, so on, a and so on is called arithmetic sequence or arithmetic progression if an plus 1 is equal to an plus b, right? An plus 1 is equal to an plus b, where n belongs to natural numbers, right? So this is nothing but what? To get a term, I am adding a constant or a fixed number to its preceding term. See here, it is n plus 1 and it is n, right? N is the preceding term of what? N plus 1. So to obtain the term of the progression or a sequence, I am adding the fixed number to the previous or the preceding term, right? So this is nothing but what? Arithmetic progression, right? So write this down. So in the next class, we will begin with the problems based on what? Arithmetic progression, right? So thank you.